IEEE 802.5 token ring standard is particularly important because it is the basis of IBM's strategic architecture for local area network technology. Many other vendors also market equipment and software that is compatible with IBM's token ring products. The IEEE 802.5 token ring standard defines a logical model that is similar to the other IEEE Project 802 medium access control standards. The OSI data link layer is divided into a logical link control sublayer and a medium access control sublayer. Below the MAC sublayer is the physical layer. The standard also defines the characteristics of the physical transmission medium called the trunk cable, a trunk coupling unit, and a medium interface cable used to attach the LAN adapter to the trunk coupling unit. The IEEE 802.2 standard defines the logical link control sublayer. IEEE 802.5 defines the components below logical link control. A token ring network consists of a logical ring implemented using a physical ring topology. Data units that flow from station to station around the ring consist of tokens and MAC frames. A token is a special 3-byte bit pattern that is passed from one station to the next around the ring when the network is idle. A station must wait for the token to arrive before it can send a frame. It then changes one bit in the first 2 bytes of the token to transform it into a start of frame sequence. It next attaches the remainder of the frame to the start of frame sequence to create a complete MAC frame and then transmits the frame to the next station on the ring. When a station begins transmitting frames, it starts a timer and can then send frames until either it has no more frames to send or until the timer expires. MAC frames are of 2 types. Frames that contain logical link control protocol data units, or LLC PDUs, that were passed down from the LLC sublayer, and control frames that are generated by the MAC sublayer to control network operation. Each station acts as a repeater and transmits each frame that it receives to the next station on the ring. Each station that receives a frame checks the destination address field in it to see if the frame is destined for that station. Whether or not it accepts the frame for processing, a station always transmits a frame that it receives to the next station on the ring. When the frame finally returns to station B, the station that originally sent it, it removes the frame from the network by not transmitting it to the next station. If station B has no more frames to send, it turns the start of frame sequence back into a token and transmits it to station C. This allows station C to begin transmitting frames of its own. As each MAC frame passes around the ring on its way back to the station that originated it, each station has an opportunity to set control bits in the end-of-frame sequence of the frame's trailer. These control bits indicate whether or not the frame was processed by a particular station and whether any transmission errors were detected. 3 control bits in each MAC frame are defined for these purposes. An error-detected bit indicates that an error condition was detected. An address-recognized bit in the trailer indicates that the destination station identified this data unit as being addressed to it. A frame-copied bit in the trailer indicates that the destination station passed a copy of the LLC PDU up to the logical link control sublayer for processing. Different combinations of the address-recognized and frame-copied bits allow the source station to differentiate between different circumstances. For example, the frame was processed, or the destination station recognized the frame as being addressed to it, but was unable to process it. Or the destination station either did not recognize the frame or the station is non-existent or inactive. There are two error conditions that can impact the operation of a token ring network: the loss of the token and an endlessly circulating frame. In order to handle these two error conditions, it is necessary for one of the stations on the ring to assume the function of an active monitor. The station designated as the active monitor continuously monitors network activity. If a predetermined period of time elapses during which the active monitor does not receive a token, it assumes that the token has been lost, creates a new token, and starts it circulating. To detect an endlessly circulating frame, the active monitor sets a monitor bit in each frame that it receives. If a MAC frame returns to the active monitor station with a monitor bit still set, the monitor knows the source station failed to remove the data unit from the network. The active monitor removes the frame by changing the start of frame sequence into a new token, discarding the remainder of the frame and starting the new token circulating. Two situations can cause an endlessly circulating frame. A transmission problem may have damaged the frame so that the source station does not recognize it as its own, or the source station may have failed. All other stations on the network act as passive monitors and check the operation of the active monitor. If for some reason the active monitor fails, the passive monitors use a contention resolution procedure to determine which station should take over the role of active monitor. Another type of failure that can impact a token ring network is the failure of a station. If a station fails, it may no longer be able to transmit frames, effectively breaking the ring. Because of this, each station on the network is normally connected to a bypass switch. Although the LAN wiring must take the form of a ring, stations are most often connected in a star configuration using wiring closets. Each station is connected to a bypass switch, sometimes located in the wiring closet. If a station fails, the bypass switch can be closed, either manually or automatically, restoring the ring, even if the station can no longer relay frames. Token ring access control can be operated on either a non-priority or a priority basis. When the optional priority scheme is not implemented, a station can send frames whenever it receives the token. When the priority scheme is implemented, 3 bits in the header of each frame indicate the frame's priority. A token also has a priority value. When a station receives the token, it compares the priority value in the token against the priority of any frames that it has to transmit. If the station has a frame to transmit with a priority equal to or higher than that of the token it is holding, the station transmits that frame. If frames have lower priorities than the token, the station does not transmit those frames and passes the token to the next station. Each frame also contains 3 reservation bits that stations use to request a token that can be used to transmit frames of a lower priority than that of the token currently circulating. The reservation system makes it possible for lower priority frames to eventually be transmitted. The IEEE 802.5 standard describes a form of token passing in which stations are arranged in a physical ring, often using star wiring. You have seen a model of the IEEE 802.5 architecture, procedures for passing the token from station to station, demonstrations of other aspects of the token ring MAC protocol, an introduction to error detection and correction procedures, and a demonstration of the optional priority scheme. Please turn to Mini Course 1 in your personal reference guide and continue your study.